Welcome to Burlap Teachers. Enjoy the video.
You start by preparing the environment so you can iterate fast. Create a virtualenv and install speech recognition, PITSX3 and Pi Audio. These provide audio I/O, SDT, and TTS. Plug in or enable your microphone, then run a quick recording test to confirm levels. Once done, write the minimal script that captures audio frames and sends them to the recognizer. This first working capture proves the pipeline. Make sure audio sample rates match between device and libraries to avoid distortion. Now build the main loop that listens, transcribes, and responds. Use adjust for ambient noise to calibrate. This reduces false positives in real environments. Decide whether to use an offline engine like Pocket Sphinx or a cloud API. Cloud gives accuracy but adds latency and keys. Parse transcribed text into intents with simple keyword matching or rejects, then route to handlers. Finally, call PITSX3 to speak responses. Make sure to run TTS on a worker thread so audio playback does not block listening. Finish by mapping parsed intents to concrete actions, shell commands, HTTP API calls, or device control. Add a wake word detector or push-to-talk to avoid continuous processing, then log transcripts and outcomes to simplify debugging. Wrap the app with Pi installer or create a service for startup. If something goes wrong, check device indexes and permissions first. Often the recognizer gets silence because the OS selected the wrong microphone. Retest with a different mic and verify sample rate consistency.
Thanks for watching. Consider subscribing if this video helped you.